Hello everybody, today we're going to talk about chapter 9, which is about cryptography and public key infrastructure. So in this chapter we have three agenda items. We have three main things to discuss. Firstly, we'll start with the definition of cryptography, difference of cryptography with steganography, and the role, why do we need cryptography. I'll establish a question, a need of cryptography, and then we will talk about the types of cryptography, and specifically we're going to talk about two types: symmetric and asymmetric. So please remember one thing: symmetric cryptography or asymmetric cryptography is also known as symmetric is known as private key cryptography, and asymmetric is also known as public key cryptography as well, public or private key cryptography. So first of all, let's start with the definition of cryptography, from where the word cryptography came from. So basically, the main field is cryptology. So cryptology is basically main field which encompasses cryptography and cryptanalysis. Cryptography is basically art of secret writing, and the word cryptography came from Greek letter krypton, graphene. That's basically the word from where the cryptography came from. So crypto means secret, while graphy means writing. So if we would like to define what is cryptography, so the definition will become the art of secret writing is called cryptography. Art of secret writing is called cryptography. Another definition of cryptography is basically scrambling of the data in such a way that only legitimate individual can recover or read the data. So that's the definition of cryptography. I'll explain you in detail with examples. Cryptanalysis is a counterpart. Otherwise, you can say cryptanalysis is basically breaking of secret data or secret code. So breaking of secret codes, or you can say finding vulnerabilities of secret code, is called cryptanalysis. So let me give you a basic idea about cryptography, just to make you understand as a black box what cryptography is. So in cryptography there are two main characters. One is basically sender. For example, this is our sender. Okay, for example, Alice, she's our sender, and we need to have a receiver. So let's say we have this receiver, and the receiver is Bob. So what we are trying to achieve with cryptography, we want them, Alice and Bob, should communicate in a secure fashion. Let's say we are assuming that there is a wireless channel in between. So, and there might be some intruders, some sniffers, and we don't want our data or messages to be sniffed. So what we're going to do is we're going to use cryptography. So only legitimate party, which is Alice and Bob, they can read the data. In order to do that, what else we need to do is we need to Alice and Bob both have to have they have to agree on an algorithm, a secure algorithm. They need to know a key as well. So both the parties, they have to agree on an algorithm and a key. Okay, that's basically how cryptography will work. Let me give you a simple example. So for example, Alice, let's say this is sender, and for example that's the receiver. So we have a message is, let's say, ABC. So sender wants to send a message ABC to receiver in a secure form using cryptography, and we know that there might be some sniffers in between. So what we need to do is we need to transform the message in a secure form that only receiver can actually receive or interpret the message. So what we're going to do is we are assuming that both of the parties agree on algorithm, they are agreed on a key. Same is the case with receiver. Receiver is agree on algorithm, receiver is agreed on a key as well. So algorithm is, for example, let's say over ABC is the message, for example, and let's say algorithm is we are using a simple substitution cipher. we are going to substitute the letters with the other letters. And let's say key is equal to 1. So in substitution cipher, and if key is equal to 1 means substitute the letters with the next letter down the alphabet. For example, let's say if you want to send ABC, if you use substitution cipher, if you pass it substitution cipher, having a key equal to 1, so A will become next letter B, B will become the next letter down the alphabet C, C will become D. So now this is called my ciphertext, and this whole process is called encryption process, which we are doing at the sender side. At the receiver side, when receiver gets the message BCD, receiver already knows the algorithm, receiver already got the key, receiver will use the same algorithm but in reverse fashion. Receiver knows that these are substituted message with the next letter. Receiver will take them back B. If we take it back, shift it back to previous point A, B and C. That's the way how both legitimate parties, they can exchange a secret message. So if anybody sniff the message, because over the channel we are just transmitting BCD, if anybody sniff, they will get only BCD, but original message was ABC. This complete process is called encryption, and receiver side, this is called decryption. Whole process is called cryptography. Another better example could be, for example, if the message is hello, let's say that's the message. Using the same algorithm, what will be the ciphertext? H, I, E, F, L, M, L, next letter, M, O will become P. So these are basically next letters down the alphabet. So that's the ciphertext. So instead of sending hello, if we use this particular method, so if MMP will be the message. When it gets to the receiver, receiver knows that these are substituted messages with the next letter, so they will take them back. Okay, so that's basically somehow just a basic idea, basic concept of a cryptography. So there's a very closed term of cryptography which is called Steganography. And steganography is basically, some people they confuse cryptography with steganography. Steganography is basically hiding or concealing data within another data or file, within another file or data. This particular is called steganography, when you hide the data within another data. For example, this is a text file. Let's say this is my text file. It's a very secret file. I just want to hide this file in a PDF file. So or maybe it could be an image. So if you hide a text file or a PDF file within another PDF or another image, this process is called steganography. The receiver has to have the same tool, same strategies in order to recover that particular message. That is steganography. We will use a tool called OpenStago in our lab, so please stay tuned, and I will upload the video for the lab as well, so you can actually see how exactly it works. We'll talk about OpenStago as well. So let's move on. There are a few definitions which I already explained to you guys, but let me quickly define those definitions or those particular things. One is basically called, and by the way, have you ever used cryptography? Of course, we have used cryptography whenever we use HTTPS. So whenever you use HTTPS, I've shown you guys in our Wireshark, whenever you use that HTTPS, if anybody sniff your packet, they will see the encrypted the packets. And whenever the packet, those particular packet, let's say this is encrypted packet, when it gets to your access point, what's going to happen? Access point will decrypt it, and then it will forward it to next router and all that stuff. Now, let's talk about the some few definitions that we need to know. One is the definition is encryption. Encryption is basically the process of transforming a message or a plain text into ciphertext. Ciphertext, which is basically encrypted one. Encrypted message. So ciphertext or encrypted messages, both are the same things. Second is decryption. Decryption is the reverse process which we do at receiver side. This is at sender side. So process of retrieving or recovering original message from a plain text. Is called decryption process. Let me explain you the concept of cryptography, encryption, decryption with the digital cryptography point of view, like how we do encryption and decryption in digital world. So in digital cryptography, firstly, we need to understand one thing. The first most widely used algorithm, or you can say the function, is XOR logic function. You need to understand the XOR logic function, and let me write down a truth table. So let's say we have two input, X and Y. Both input can be 0, 0. X can be 0, it could be 1, it could be 1, it could be 0, or both could be 1, 1. So if you take XOR between these two input, output is gonna be, if two inputs are same, output will be 0. If you just take XOR between them, like XOR, this is the symbol of XOR. So if two inputs are same, output will be 0. Two inputs are different, output will be 1, different, 1, same, 1, 1, 0. So this is the main idea that we're going to actually implement in our digital cryptography. So let's understand this idea. So for example, we have sender. Let's say we have a sender here, and let's say this is receiver. So sender has basically a message. M is original message. Let's say message is 101101. So for example, that's the original message. And for example, the key, the secret key is, which is shared between sender and receiver, 001011. For example, that's the key. Receiver already knows the key. So receiver knows the key and the algorithm. Let's say 001011. So that's the key. Now what's going to happen? We will apply the simple XOR, and XOR is just the algorithm M XOR K. So 1, 0, two input, two values are different. What will be the answer? Different, 1. Same, 0. Same, 0. Different, 1. Different, 1. Same, 0. So this process is encryption, and this output is called ciphertext. And this is what we will transmit over insecure channel. Now when this particular message, the ciphertext will get to the receiver. Receiver sees for ciphertext, and this is ciphertext 1, 0, 0, 1, 1, 0. So receiver will repeat the same process but with the key. So 0, 1, different, same, different, different, same. So this is 1, sorry. Different, 1. Do you see the same message came back? So this is basically the best example to understand cryptography. So if you see this example, what we did, sender has the message to transmit securely. He should have a key, which receiver already knows. When they take an XOR between message and the key, we got a ciphertext. Receiver got the ciphertext. Since receiver already knows the key, they took the XOR between them, and you can see the original message has been exchanged. So this is basically what the actual soul of cryptography is. Now, there are four main things that we actually get from the cryptography. Four main you can say traits of cryptography. The first is the confidentiality, and of course we are getting confidentiality. Confidentiality is basically only authorized people can read the contents. Unauthorized people cannot read what exactly is going on. Like if you know this key, then only you can actually get the message, otherwise not. This is the way how we protect confidentiality. Second is integrity. We will discuss integrity in detail, but just for the definition, integrity is basically only authorized people can make modification or changes. Unauthorized modification can be detected, and usually we use hash functions in order to protect integrity. So definition is only authorized people can make modification. Third, authentication. So it's a verification, whether verification of the sender, like sender can authenticate or sender can validate the receiver, receiver can validate the sender. Like I am talking to a right guy, a sender can actually authenticate whether I'm talking to a right guy, receiver can authenticate whether I'm talking to a right guy. This is another trait that we can get from cryptography. The last and most important trait is called non-repudiation. Non-repudiation is basically, it makes the people loyal. Like within non-repudiation, sender cannot disown his or her actions. So whenever sender will send a message, it's basically sender will actually use his private key to sign. So sender will always digitally sign the original, or you can say transmitted message. So of course, like for example, if you sign something, if anybody forge, so it can be detected because you can detect that, hey, this is not my signature. So in non-repudiation, we actually give a verification process, verification of signature process to everybody. We'll talk about non-repudiation in detail. This is one of the most widely used trait of the asymmetric cryptography, where we will use digital signatures. We'll talk about it. There are two more things, two more types, like types of cryptography. As we already discussed, types of cryptography. There are two main types of cryptography. One is the called symmetric, and second is called asymmetric. So in symmetric, as name suggests, same. So we use, or you can say sender and receiver use same key for encryption and decryption. So we use the same key for encryption and decryption. Like just the same example, if you see this example, that's the best example to understand. So same key for encryption, same key for decryption. This process is called symmetric encryption. We use symmetric encryption to secure the databases, but for website security and all that, we use asymmetric. In asymmetric, for encryption, sender uses receiver's public key, and for decryption, receiver uses his private key, which is only known to him, private key. So for encryption, if we use a different key, and for decryption, if we use a different key, that is also known as asymmetric encryption. So let me just make you more understand what is basically asymmetric encryption. Like symmetric is fine. Like if you wanna open a lock, for example, this is a lock. You got a same key to lock and unlock the lock. For example, one key, you can lock the door, you can open the door with the same key. But for asymmetric, which is widely used in website security, like HTTPS and all that stuff, is basically asymmetric encryption. So let's understand that with an example. So let's say, for example, an asymmetric encryption, for example, let's say we have, assume that there are two people, Alice, and for example, we have another person who wants to communicate by using asymmetric is Bob. So Alice and Bob, they want to communicate using asymmetric. So in asymmetric, please remember all the participants, or everybody, they have two keys. So Alice, she has a public key, and Alice has a private key as well. So Alice has a public key and Alice has a private key as well. So public key is something which is known to everybody, as name suggests, public. Private is something which is only Alice knows that. Nobody else knows Alice's private key. Same is the case with Bob. Bob has a public key and Bob also has a private key. So Bob has a public key and Bob has a private key as well. Private key as well. Public key known to everybody. All the people, like Alice knows Bob's public key, but private key is only known to Bob, in fact. So for example, and other than that, who also knows the public keys? So we assume that we have basically a bank of public keys. Let's say this is the bank of public keys. So this bank of public key, it has Alice public key, it has Bob public key, and if there will be any other person, it also holds their public key as well. So now what's going to happen? Let's say Alice, she wants to send a message to Bob. What Alice will do? Alice has a message. Alice will actually go to public key bank, ask the Bob's public key. So use the algorithm, use Bob public key, because the message is only for Bob. We don't want anybody else to read the message. So we use Bob's public key and we got a ciphertext. And there is a very important relationship between these keys. If you encrypt anything by using Alice public key, it can be decrypted only by using Alice private key. Same is the case with here. If you encrypt anything by using Bob public key, Bob private key can be used only to decrypt that. And so that's why if you want to talk to anybody, you can use his public key and encrypt or log the data. Same is the case right here. Bob public key will be used. Now what will happen? Alice wants to send a message to Bob. Alice will use Bob's public key, got the public key, encrypt the message. When Bob received the ciphertext, Bob will use the same algorithm, the decryption in fact algorithm, use his private key now, because the message was encrypted by using his public key, private key, and he can get the cipher, the plain text. That's basically how asymmetric encryption looks like. If you guys go to your browser, Google Chrome, if you pull the certificate of Google Chrome, which I'll show you in the lab, you can see the website like Google's public key, because your browser needs to know the Google public key in order to send the message. And when this message get to the Google's platform, they use their private key and decrypt the message. Okay, we'll discuss this from here in the next video. I'll continue from here in the next video.